Lesson 7, Adding and Subtracting Variables with Exponents. You learned earlier that you can only add and subtract fractions if they have the same name or denominator. Likewise, you can only add and subtract variables with exponents if they have the same name as well. And you can tell by looking at the base and exponent. Here's part 1, which students will complete with their instructor. In box A, we have 1 apple plus 1 apple. Apples plus apples give you apples. How many apples? We have 2 apples. Here's box B. 5 pencils minus 2 pencils. Pencils minus pencils gives you pencils. How many pencils? We have 3 pencils. Box C. Fifths plus fifths give us fifths. How many fifths? We have 3 fifths. Here's box D. 1/2 plus 1/3. And as we learned earlier, halves and thirds do not have the same name. They don't have the same denominator, so we're not going to force them together. Let's just rewrite it as 1/2 plus 1/3. Box E. 3xy plus 2xy. Just like apples plus apples give you apples, xy plus xy gives you xy. How many xy? We have 5xy. Here's box F. 9x squared minus 5x squared. Just like pencils minus pencils gives you pencils, x squared minus x squared gives you x squared. How many x squared? We have 4x squared. Box G. 4m squared n plus 2m squared n. M squared n plus m squared n gives you m squared n. How many m squared n? We have 6m squared n. Finally, box H. 2mn plus 3m squared n. mn plus m squared n gives you, and this doesn't make sense to do this, just like it doesn't make sense to add 1/2 and 1/3. So we're not going to force them together. Cross it off and just rewrite it as 2mn plus 3m squared n. And we couldn't add them together because they didn't have the same bases and exponents. They didn't have the same name. Here's part 2. Simplify. Use parentheses to group terms with the same base and exponent together, and just think apples plus apples. Take a look at box I. Here we have x squared plus 2x plus 3x plus 6, and we need to simplify this. So we know that we can add x's and x's together, just like we can add apples and apples together. So let's group them together. And now let's go to the next line and simplify. Here we have x squared plus 2x plus 3x gives you 5x. And here we have plus 6. So our final answer, x squared plus 5x plus 6. Here's box J. X squared plus 4x minus 7x minus 28. And we can simplify 4x minus 7x. Just think apples plus apples or pencils minus pencils. Let's move on to the next line. Here we have x squared. 4x minus 7x gives you minus 3x minus 28. Let's do 2 more. Here's box Q. A to the 3rd power plus 2a squared plus 4a squared plus 2a plus 3a plus 6. So just think apples plus apples, and let's figure out what we can simplify. So we know that a squared and a squared have the same name, so we can simplify this. And also, a and a also have the same name, so we can simplify this. Next line, a to the 3rd power. 2a squared plus 4a squared gives you 6a squared. Here, 2a plus 3a equals 5a. And here we have plus 6. So our final answer is a to the third power plus 6a squared plus 5a plus 6. Last one, box R. 4a to the third power plus a squared plus 2a plus 3a plus 8. And be careful with this problem because it has hidden coefficients. So here where you see a squared, this means the same as 1a squared. And this is also 1a squared. Let's simplify the expression. Think apples plus apples and figure out which terms we can combine. So I know that 1a squared and 1a squared have the same name, so they're like terms that we can combine. And also 2a and 3a have the same name, so we can combine these like terms as well. Next line, we have 4a to the third power. Next, 1a squared plus 1a squared equals 2a squared. Here we have 2a plus 3a equals 5a. And finally, plus 8. Final answer, 4a to the third power plus 2a squared plus 5a plus 8.